So this is our next topic that we're going to talk about. We're going to jot down a few notes on arithmetic sequences in particular, and then we have another task-based question that we're going to look at the end of this lesson. You can put these notes on page 17, and the task problem will go on page 18. So we're going to be talking about arithmetic sequences, and we're going to jot down some important things about these sequences. One important thing is that the change between terms is always a constant. And that word consecutive tells me I'm looking at terms that are right in a row. So like term 4 and 5 and 6, those are right in a row. So the change between term 4, term 5, term 6, term 7 is always going to be a constant. And it's going to be the same number that's being added or subtracted. So I could see a pattern of plus 5 or minus 2 or plus 13. So whatever number I'm adding or subtracting is going to be the same number that I add or subtract through the entire pattern or sequence of numbers. That number is called the common difference. We already added that vocabulary term last week, but we're going to just remind ourselves that very important number is called the common difference. So if that common difference is a positive number, that means our sequence of numbers that we have is always going to be increasing. On the contrary, if it is negative, that means the sequence will always be decreasing. So that list of numbers that we've been given would be going down. So if we're looking at a picture, a table, or a graph, how would we know if that is arithmetic? Well, in a picture or a table, we would be able to find that pattern as being addition or subtraction of the same number. So the picture would go from 5 dots to 10 dots to 15 dots to 20 dots, showing us the pattern of adding 5. Or if I was looking at a table, I would look at the output values and I would look for that pattern of addition or subtraction as I move from one output value to the next. If I was looking at a graph, the first thing is it would be a discrete graph if I'm dealing with an arithmetic sequence, which means it's only dots. They are not connected. And those points would form a straight line. So if we're talking about when we should use a recursive formula, we would want to look at what we're trying to find. If I'm given terms 1, 2, and 3, and they ask me to find term number 5 or term number 7, those are very close together. It would be very easy for us to just use our pattern and add or subtract a few times to find our desired term. On the contrary, to use explicit, if I've been given term 4 and they want me to find term 50, using my pattern would be exhausting. We would have so much adding or subtracting to do that it would be easier for us to write the explicit formula and then use that formula to find that term 50. So this is the end of the notes for that page. For the next portion of this, we're going to be doing a task problem called Scott's Workout. You will need some graph paper and some lined paper to jot some things down, some ideas and some thinking. So again, this is going to be a new page in our notebook. This will be page 18. So you do not have to write down this description on page 18, but what's happening is he's doing some push-ups. This is his exercise routine. And each day he's going to complete a different number of push-ups, and he's continuing this pattern every day. So the first thing we're going to look at is this representation we've been given for his workout. And I'm going to switch over to my document camera. Let's focus this a little bit better. So here is a visual representation of how he is doing his workout. This is my number of push-ups for day 1, day 2, and day 3. So what I'm going to do is I'm going to grab a few colors, and I'm actually going to document my thinking right onto my picture. So I'm going to color day 1 in this pinkish shade. And between day 1 and day 2, my goal is to find where those extra push-ups have been put in my visual representation. So what I see is that these 3 push-ups here are from the number he did on day 1. Those are the same. And then he's added on 2 more push-ups in day 2. Well, if I want to put day 2 inside of day 3, these are those 2 push-ups he added. These are my 3 original push-ups. And then I have 2 more push-ups on the top for day 3. If they asked me to draw day 4, I would start with day 3. So here's what I have for day 3. And because I like to document my thinking and see where the growth is happening to help my brain later on for equations and tables, I'm going to document those push-ups from day 3 inside of day 4. And I'm going to grab yet another color. And then the pattern has been adding 2 push-ups every day. So I'm going to show those 2 extra push-ups on the top. So if I was going to write this in words, I would say that his pattern is adding 2 push-ups each day. And that's an explanation in words of what we see happening in our push-up picture. So now I want to put this into a table. So the first question I need to ask myself is, what is my independent variable or my input? So I need to think, are the number of push-ups changing based on the day, or is the day changing based on the number of push-ups? Well, we said I'm adding 2 push-ups each day. So that tells me that day is independent and the number of push-ups is dependent. So I'm starting on day 1 and I have 3 push-ups. Day 2, there are 5. Day 3, there are 7. Day 4, there are 9. And if I wanted to, I could add day 5 and day 6, and that would be 11 and 13 by doing that pattern of adding 2 every time. So here I did +2, here I did +2, here I did +2, and so on. And this pattern here, the +2 pattern, is going to help me write my recursive formula. And my recursive formula is the one that was in words, where I'm using my output. The next output I got by doing what I have now plus 2. Now I also could think about making a graph from my table. Now I have already created my graph, but this is the graph that I have created from my days and my push-ups. You'll notice that these are points that are not connected. This graph is discrete. And that's because if I connected the dots, I would be saying that there could be a picture in between these two pictures for day 1.237. And that doesn't make sense based on the scenario we've been given. Now, because I want to make sure that I can see that pattern of +2, I'm going to look at this change here. Here is my increase of 1 day and my increase of 2 push-ups vertically. I moved to day 3 and I have gone up 2 push-ups. I moved to day 4, I have gone up 2 more push-ups. So I continue to see that vertical change of +2 as well. So now I have a picture, words, a table, a graph, a recursive formula, but what I don't have yet is an explicit formula. And I'm going to bring my picture back because our picture is going to help us solidify what I'm doing for my explicit formula. So explicit formulas, we can use any day number, substitute that into an equation, and automatically get my number of push-ups. I cannot do that with recursive because I need to know the previous output. That's the biggest difference between explicit and recursive. Recursive is outputs only, and explicit is using an input to find an output. So what I'm going to do is actually rewrite this documentation of my new push-ups on my table. So here I have my 3 push-ups. For day 2, I have 3 push-ups plus 2 more. For day 3, I have 3 push-ups plus my 2 orange push-ups plus my 2 green push-ups. Day 4, I have 3 of my pink plus my 2 orange plus my 2 green plus my 2 blue. If I wanted to continue that and think about what's happening for day 5, well, I would see my 3 pink, my 2 orange, my 2 green, my 2 blue, and then let's say I would have 2 purple. So the question I need to ask myself is, how can I relate the number of +2 push-ups that I have at each step to the step number itself? So how does this 1 plus 2 relate to that 2 there? How does 2 relate to 3? How does 3 relate to 4? And how does 4 relate to 5? And here I have no +2's. How does that relate to 1? Well, the number of push-ups, this is like 3 plus 2 times 4. This is like 3 plus 2 times 3. 3 plus 2 times 2. 3 plus 2 times 1. And 3 plus 2 times 0. So my goal is to figure out, how does this number inside of the parentheses go back to being related to the day? Well, I have 0 plus 2's on day 1, 1 plus 2 on day 2, 2 plus 2's on day 3, 3 on day 4, and 4 on day 5. This number in the parentheses is always 1 less than the day number. So if I call the day number n, and you remember that funky notation we looked at, a sub n, and again, that's just a way to write output. It's like saying y equals or f of x. For my explicit, what I'm doing is I'm taking 3, I'm adding 2, but the number inside of the parentheses is 1 less than the day. And that is my output. So I'm going to do a little bit of further explanation here. This will be my output for that term. For term n, this 3 is called my initial value. Because that's the first number of push-ups I had. 2 is my common difference. N is my term number. Whatever term number I'm talking about. And then I have -1. This is my initial term number. Oops, I'm spelling initial wrong. So my initial term number was 1. My initial value of push-ups was 3. My common difference was +2. And then n is for any term I could think of. And a sub n is just my output. So for example, if I asked you to find how many push-ups there would be on day 15, that would mean that my n value is 15. So I can use my explicit formula here. So my output for day 15, that's what this means. Output for day 15 is going to be equal to 3 plus 2 in parentheses. Now I have n being 15, and I'm going to take 1 away. So that would be 3 plus 2 times 15 minus 1 gives me 14. 3 plus 2 times 14 is 28. So 28 plus 3 gives me 31 push-ups. So my answer for day 15 would be 31 push-ups. And that's just an example of why sometimes it's easier to have the explicit formula, because I wouldn't want to go back to my table and add 2 a bunch of times. I'd rather just use explicit.